So let's start with point number 7. How can we improve SQL Server performance by using Database Engine Tuning Advisor? SQL Server performance largely depends upon how you have created the indexes, that is your cluster index, your non-cluster index, etc. Now I'm sure that most of the times developers do not even think about indexes. So what happens is, by default, SQL Server creates a cluster index on the primary key, and that's the only index you will find in most databases by default. And non-cluster index, I'm going to say, if you have not given a thought on cluster index or indexes, I will say the non-cluster index is far away. Now what happens is, when these default settings are taken to production, okay, it doesn't work out for a long period of time, or it doesn't work out, as your workload increases. So as the workload changes over a period of time, in other words, as the rows increase, right, these indexes are not able to cope up and your SQL Server performance starts degrading. In other words, as time passes by on a production server, you would like to go and rethink on your indexing strategy. Now this rethinking of indexing strategy, it's not so simple. In other words, it's not just going and right clicking and recreating the index or something, right? It's a bit of a complex process. It's a 3-step process. The first thing what you have to do is basically you have to go and collect the workload. So in other words, when you deployed your indexes, right, or when you created the indexes first time, must be the workload was 10%, and now the workload has gone 80%. So first you would like to collect what is the amount of workload you have. And then you would like to analyze that as per this workload, are the current indexes or the default indexes, are they appropriate? If they are appropriate, it is fine. Must be you have to hunt around something else, to find that where the SQL performance can be improved. But if they are not, then you would like to go and update the indexes, as per the workload. So in other words, it's a 3-step process. First, you collect the workload. Second, you analyze, if the indexes are appropriate as per the workload, and then you go and update your indexes. Now, both of these activities, that is collection of the workload as well as, to analyze if the indexes are appropriate as per the workload, cannot be a manual process. You would like to use some kind of tool for this. Because in case, let's say that you are working on a database which has thousands of tables and a lot of stored procedures and it has a lot of transactions, it's humanly not possible to go and analyze that workload and come up with accurate index plan. So for the same, what SQL Server has done is, basically it has provided 2 tools. One is the SQL Profiler, and the other one is a Tuning Advisor. The SQL Profiler will help us to automate the collection of the workload, while the Tuning Advisor will help us to take the workload which has been gathered by the SQL Profiler and come up with appropriate indexes. So let's do a small practical demonstration here, and in this demonstration what we'll do is we'll pick up a database, we'll pick up a couple of tables from the database, and we'll first collect the workload by using SQL Server Profiler, and then we'll run the Tuning Advisor on the workload to see that if the indexes are appropriate or not, and then we'll see that how the performance basically improves after using the Tuning Advisor. Now, in order to demonstrate, how to use the profiler as well as the Tuning Advisor, here's a simple sample we are going to do. I have a customer database here, and this customer database has 2 tables here. One is the TBL_company, and the other one is the TBL_customer. Now, the TBL_company has approximately, like 3000 records, so 2974 records it has, while the TBL_customer, it has like hardly 5 or 6 records. Okay, and both of these tables, don't have indexes. So for example, if I go to TBL_customer and if I see for the indexes, currently there is no index for now, and the same for TBL_company, currently there is no index for now. So if I go to the design and if I go to the indexes, currently there is no indexes on both of these tables. So one of the tables has, that is the TBL_company has approximately 3000 records, 2974, and the TBL_customer has 5 records. Now let's say that on these 2 tables, following kind of SQL queries are fired from application. So let's say from a ASP.NET application or from a C# application, right? Sometimes the TBL customer is searched by customer ID, the TBL company is searched by company ID, and sometimes the TBL company is also searched by company ID as well as the company code. So this is like these are the frequently fired select statements on these 2 tables. Now I want to iterate one point that TBL company is having like approximately 3000 records, while TBL customer just has 5 records. So now what we'll do is we will use this select nature Okay, and we will generate a workload file using the SQL Server Profiler. So what we'll do is we'll fire the select statement at the backend, we'll run the profiler, and we'll first generate a workload file, and then once we generate the workload file, we'll take that workload file and then we will use the tuning advisor to see that what kind of indexes it suggests us. So let's go and first run the profiler here. So click on tools, click on SQL Server Profiler, and click on connect. Now before I go ahead and I run this tool, let me just talk about what exactly is a SQL Server Profiler. SQL Server Profiler is a nice tool which basically helps you to capture what kind of SQL statements are fired on your SQL Server. So when I click on run, you can see that basically it has started capturing a lot of events here, or it has started capturing a lot of activities which are happening on a database. So for example, you can see that it's capturing that there are some SQL statements which are getting fired on report server. There are some SQL statements which are probably notification SQL statements, etc. So in other words, SQL Server Profiler is nothing but it's like a listener tool which sits at the back end and quietly hears what kind of SQL statements are getting fired on your database. And this tool is heavily used when you want to debug application, when you want to know what kind of select queries are fired and what kind of data has been sent to the select queries or to your SQL queries. Now okay, now that we are running this tool, there's one big problem here. The problem is that it is capturing a lot of SQL statements which are probably not relevant to us. For example, you can see that it is capturing SQL statements which are fired on report server. It is capturing some SQL statements which are fired on what you call like for the notification services, must be for the log purpose, etc, etc. And what our main goal is, we want to basically go and see that how we can improve performance on the customer database. So we are not really interested in hearing what's happening on the report server, or we do not want to capture the workload which is not relevant to our tuning currently. So what I'm interested currently is I just want to hear SQL statement which are getting fired on customer database, and I just want to take those SQL statements as my workload and then do the fine tuning. So in other words, I would like to go and remove this noise over here, which is not relevant, or probably it would not add any value for my tuning in my tuning activity. So in order to basically go and remove this noise, what we can do is we can go and put up a filter here. So let me go back again and fire the SQL Profiler, and this time let me put up a filter. So there goes my SQL Server Profiler. Connect. Now because our activity is more relevant towards tuning, what we will do is that we will not select the standard default template, but we will select the tuning template. So this tuning template is provided by SQL Server itself, and it's it basically, if you click on the tuning template, you will see that basically it just listens to the SQL statements and the RPC statements. So basically that's what we want. So basically first go and select the tuning template, and second we would like to go and put a filter. So let me go to columns filter here, and let me say that I am just interested to hear SQL statements which are fired on customer tables. So customer database, so my database name is customer, right? So now what will happen is that it will no more hear to other databases like report server or any other database, but it will only capture SQL statements which are relevant to the customer database. So let's go and fire the SQL statements which we had written. So I'm firing it a couple of times here, and you can see that my SQL Server Profiler has captured the load over here. And if you note over here, he has only captured the select statements which are fired on the customer database because we have put a filter on them. Now what I would like, I would like to save this workload, and then I would like to run the tuning advisor on the workload to get suggestions. So let me go and stop the profiling for now, and let me save this workload file. Now in order to save this workload file, what you have to do is you have to create it as a trace file. So you can see that there's a file over here. Just go save as and trace file, and let me give a nice name to this called as optimization. Let me just save this over here. So I have saved my workload file. Now the next step is I have to go and run my tuning advisor on the workload file. So click on tools, click on database tuning advisor, and provide your work file over here. So go and browse this, and I'm going to go and select this optimization.trc which I had recorded just now. And because I want to just run this optimization on my customer database, so I'm going to go and select just that database, and you can see at the top there is a button called as Start Analysis. Just hit on it. Now there is some kind of error here, you can see. So let me just click on the error. What it is saying is that it needs some extra space, basically to run your what you call your tuning advisor. So what you have to do is go to the tuning options and go to the advanced options, and what we'll do is we'll just say, okay, for the recommendation, right, for the max space, I'm just providing 5 MB over here. Now let's go and rerun the analysis. So let me just hit on Start Analysis again. So there's an analysis and recommendation. So the first thing what is noticeable here is that how much % you can improve if you implement this recommendation. So you can see that it has given out one recommendation here, and what it says is that your performance will improve 34% if you're going to implement this recommendation. Now in order to see what the recommendation is, what you can do is currently it has only one recommendation, you can see over here. So let me just click on this link here, on the definition link, and you can see the SQL preview of the recommendation. So what it says is that if you go and create a non-cluster index on the company code and the company ID, your performance will improve like approximately 34%. Okay, now if you remember, right, in our SQL load which we have given, right, we had one select query which had the combination of company ID and company code. So by looking at that combination, right, it has given you a recommendation of creating a non-cluster index, a combination non-cluster index on both of these columns. Now the next question which you will ask is, what happened to our select TBL customer? Because okay, it gave recommendations to TBL company, but for TBL customer it has not given any recommendation. Now one point you need to remember, right, is that the TBL customer had very less number of records. So let me show you what it thinks about the TBL customer. So let me click on the progress tab here. You can see that there is a small statement which is written here. And what this statement says is that the TBL underscore customer is very small. So you can see that the reason is the statement references only small tables. So for small tables, there is no point in giving index suggestions, because indexes uses B tree structure or your balance tree structure, which is far complex than doing a table scan for small tables. So what it is saying is that currently whatever is the scenario is good. Probably creating indexes will complicate the matter further. So you can see that basically how it has given recommendations, also how it has given reasons for where he has not given the recommendation. So I hope that you liked this video, and in this video what we did is basically we looked into how to go and create a trace file or a workload file by using the SQL Server Profiler, and then on the SQL Server Profiler we basically ran the index tuning wizard or the database tuning wizard to see that how it gives out recommendations, and we can then apply those recommendations to improve our performance. So I hope that you have enjoyed this part of the video, and we'll keep continuing the SQL Server performance tips in this section as we go ahead. Thanks a lot.